Hello everybody, welcome to today's video on the F-100's throttle and how to keep yourself out of trouble. So this topic deals with the method of controlling the fuel flow to the engine using your throttle. And obviously when working with a topic like this, we are forced to focus only on the essential points. Obviously, people spend entire careers engineering fuel flow systems for turbine engines and all kinds of applications. So if anyone has questions about the specifics, I'm sure there's room to talk those through in the comments. But the high points that matter for those of us in DCS are this. As you can see, the J57 engine in the F-100 can and certainly will compressor stall if you mishandle the throttle. Now, fortunately, this is not an issue that cannot be overcome, I should say. If you can take a couple of points in mind, you can fly the F-100 and your odds of having this compressor stall happen while you are, say, in a dogfight or a bombing pass is going to be minimized significantly. The first point to understand here is that the throttle system on this F-100 is not the same as what you would find on a modern F-16, MiG-29, or similar. Modern aircraft use computers that manage the engine in a way that the throttle and fuel supply and all those interactions are relatively straightforward. You can maneuver the throttle however you like, and the airplane will do generally a fairly good job of taking the data points of what the airplane's doing, computing how to manage the engine and its fuel flow and those kind of details, to then deliver the thrust or non-thrust that you are asking for by moving the throttle. And of course, the ultimate fulfillment of that system is the multifunction quote-unquote throttle in the current F-35, where you don't even have direct control of the engine. It's just a lever that tells the computer system what you want the airplane to do based on the situation that the airplane happens to be in. So take that system and how it works and compare it with this, which is the mechanical clockwork that is behind the engineering of the J57, which is an engine that was designed in the 1940s. So no real computer brain power is happening here. It's all mechanical, which means you get this if you mishandle the throttle. There's no black box, there's no software logic, there's no sophisticated full authority digital engine computer that's just translating what you're doing into what the engine should do. It is raw mechanical action, period. But all is not lost here. If you understand how this works and that this is all basically gears and clockwork, you can also understand how to keep yourself out of trouble and even take advantage of its perks. So the first thing to understand is, while going slow may be beneficial, it's not necessarily the goal. The goal is to stay ahead of the engine. So if you pay attention to the RPM of the engine, obviously the louder the engine is, the harder it's working, right? And hopefully, if it's working harder, it's because you're going faster, right? So if you hear the engine spooling up and you're moving the lever forward, that's not a good time to suddenly decide to snatch it backwards. Now, such behavior may be okay on an F-16 that has 15 different computers calculating the engine and behavior of it to then take your throttle measurement and make the appropriate adjustments to the F-100 or the GE F-110 engine, that whatever may be in your F-16 block variant, to then proceed without any compressor issues. However, with a jet like this, again, old school clockwork. If you snatch the throttle back while you're bringing it up, the engine's going to choke. And the same thing's going to happen if you're bringing it down and all of a sudden decide to change your mind and spool it back up. So what is the approach here? Well, the approach is just stay ahead of the engine. If you hear the engine spooling up and you're bringing the throttle up and you decide, okay, now we need to slow down, leave the throttle where it is and maybe use your speed brake, or maybe turn a little harder, or do some pilot stuff to try to slow yourself down if you find yourself in the need to suddenly manage your speed. Likewise, if you need to increase speed, don't snatch the throttle forward, because you're not going to get more speed by just slamming it all the way forward. You're going to get a bunch of pops and bangs and shakes and shimmies. So don't do that. Since slamming the throttle forward doesn't get you anywhere in the F-100, you may as well take your time. And if you just bring it up in line with the sound of the engine, generally speaking, that will keep you out of trouble versus doing something like this where you slam it forward and you get the pops and bangs of an unhappy J57 engine. So, incidentally, Grinelli's team's done a great job modeling the airplane movement and how it kind of rolls. It doesn't just shake and shimmy, it actually turns on its axis because a J57 engine is turning within the airplane. So pretty cool little detail there. Anyways, hopefully this little explainer helps. Again, the topic of engine and throttle management and that kind of thing is literally complex enough to constitute an entire career, so we're not going to go into that. But this is just a high level look at ways of managing your throttle and your power delivery so that you can fly your F-100 to the best you can without worrying about the engine going on strike at the wrong moment. Thanks for tuning in. Catch you in the next video.